Hi everyone. Thank you for being here. I can't really look at other screens, so I'm just going to get started. My name is Magda, or you can call me Marie. I'm on the pre-sales team here at Fiddler. I also have Mary with me, who is our lead data scientist, as well as Henry, who is our senior product marketing manager. So in terms of agenda, I'm just going to start us off by giving you a little background on some of the challenges we're seeing in the MLOps community, as well as what Fiddler helps solve for. And then Mary will provide an overview of or a demo of what Fiddler looks like. So just a bit of a background. Our mission at Fiddler is to help build trust into AI by fully automating model performance management as well as bias and explainability. Oops. So most teams are now currently using a lot of data science, and as they're deploying more and more models, a lot of enterprises are facing four of these main challenges. One is issues with model transparency. So a lot of teams don't really have visibility into why their model is giving the output that it is. And there isn't really visibility into how the model is performing over time, whether there is bias happening or whether there is a drift. And what we're also seeing in insurance and banking companies is that they're becoming more and more regulated. So regulators and auditors are asking into visibility into the model. So we believe currently a lot of AI teams are flying blind. So just to reiterate on what I mentioned before, as teams are deploying more models, a lot of them are becoming black box. And different teams are asking different questions into how the model works. For example, business users are asking, can we trust this model? Auditors and regulators are asking, is the decision being made by this model fair? And data scientists are asking, how does my model work? So currently, there isn't really visibility into model performance, or most of it is being done in an ad hoc manner. There isn't really any type of monitoring to catch bias or drift that might be happening. And there isn't really any consistent explanation on model behavior. As mentioned before, a lot of it's just being done in ad hoc manner or by patching together open source tools. And obviously, over the last 2 to 3 years, we have spoken to multiple customers who have validated a lot of what we've been hearing in the market. So these are some of the real quotes from customers. And I can give an example of some of them. We had a data science tool who told us that they had a drift happening over the weekend that cost them over $500,000. We also spoke with a data scientist who told us she has a PhD in data science, and she tried to put one of her models into production, but the model never made it because it wasn't really trusted by business users. I'll give you a few seconds to read some of those. And so I went over some of the challenges we're seeing, and this is why we created Fiddler. Just to give you a little bit of background, these are our leaders. Obviously, they come from enterprise companies with lots of experience, but the idea of Fiddler actually came from our CEO, Krishna Gadi. During the 2016 elections, there was a lot of mistrust in Facebook, and he was a lead engineer, and he worked on this project that shows you every time you're being targeted by an ad, post, or anything, it generates it's like, why am I reading this? And every time we click on it, it generates a human readable explanation on why you're being targeted by that post. And what Krishna realized was that it wasn't just Facebook who was suffering through transparency, but a lot of enterprises were also having similar issues. And that's when he decided to create Fiddler. And so what we bring to the market is an application performance management-like tool, but for AI and machine learning teams. So think of it as what Tableau did for product teams and what Datadog is doing for DevOps teams. That's what Fiddler is doing for AI and machine learning teams. So we provide a centralized platform to help teams to continuously explain, monitor, and analyze their models. So with Fiddler, teams can get visibility across all their models. They can also understand whether there's anomalies or performance decay happening over time and catch whether there's bias. And they can also generate granular explanations on their data and models, which can then be served to either the model validation team or whoever would be consuming that model. And obviously, they can set up like critical alerts and insights into how the model is performing, so they can never like miss an issue if there's an anomaly happening. So in terms of where Fiddler sits in the machine learning lifecycle, we sit at the heart of it. And what we do is we provide value in each step of the machine learning lifecycle. So when teams are training their model, they can use Fiddler to check for bias as well as like check for feature quality. And then they can generate explanations, which can then be used to validate that model. Once the model goes online and is now deployed, then they can continuously monitor the model for any type of like performance issues or bias, drift, or outliers that might happen. And if, let's say, in an event where there is a drift happening or there's a performance decay, they can quickly go in, check the model with and get to the root cause analysis, and then debug the model and put it into production again. So we pretty much create like a closed loop system where teams can continuously monitor, validate, and redeploy their models. So we, instead of like babysitting their models, teams can now focus on building newer models that will generate revenue. So just to conclude on what I touched on, with model performance management, it reduces many operational risks. One of is with performance degradation that happens over time. It also helps prevent bias before it becomes like a business problem. It also helps check for data quality issues or bugs that might have made it into the data flow over time. And also prevents like black box model by providing deep explainability and holistic overview of your model. So currently, we're working with multiple banks in the United States to evaluate and explain like why a model is behaving the way it is. And the machine learning engineers are using Fiddler to monitor for any type of trends or anomalies. And obviously, we're not just working with banking customers. We have customers across different industries, as well as across all stages of growth. And these are some of our customers. So we are currently working with e-commerce like Etsy, gaming with like 2K Gaming, as well as a few others. So in terms of where Fiddler would integrate, we are a pluggable platform. So that means that we can integrate whether you're on-premise, on cloud, or in your own private VPC. And we integrate with any type of modeling framework, whether that is SAS, Python, or H2O. And think of Fiddler as like an extra layer of cake that sits on top of your existing tool stack and then connected via an API. So that means your team doesn't really have to change their existing workflow or their infrastructure to integrate with Fiddler. And so getting to the most exciting part, to get started with Fiddler, what we need is just the training data that you use to train your model. And then you can start sending your prediction log and you can start monitoring your models. But if you are looking for more deeper explainability, then you have the option to register your model with Fiddler. Perfect. So with that being said, I'm going to pass this on to Mary, who will be providing us with a demonstration of the Fiddler platform. And I'll stop sharing my screen.
Thanks so much, Magda. And hello, everyone. Even though I can't see you, it's nice to be here with you all. Let me just pull up the demo for you. So as Magda said earlier, I'm a data scientist at Fiddler. And let's just jump right into the platform. I want to kind of give you all an overview of, what our product looks like and some of our capabilities. So this is really our landing page here. So you can see, and can you guys see my mouse when it moves or no?
Yep.
Great. Okay, excellent. So you can see that it's divided up into various projects here. And within each project, you can list models that are associated with that project. So say I'm interested in my bank churn project. So I'm going to select that, and I can immediately see, we have a variety of models that are associated with that, as well as any data sets that are associated with each model. On this sort of overview page, you can see if there's been any sort of monitoring traffic that's been sent in the last 7 days. Kind of gives you the ability to look at alerts. If we've been tracking performance for the models, you can see that as well, or any sort of data integrity violations. So I'm going to zoom in one step further, and so sort of plug into one specific model. Now, again, this is, we're trying to track banking customer churn, okay? So in this case, it's a binary classification, and that's whether or not a customer is going to churn or not. So our target is yes, no for churn. And in this particular case, we're using a random forest. So this is sort of the details page that we show our users, for the model that they've uploaded with their information. Again, you can look at, what your output is going to be. Here, there are the variety of features. This is just sort of an overview of your model, the particular data types for each of those features. Then we have here the feature distribution. And so this is associated with your training data. And then we have our global feature impact here. And so if we want to zoom in, a little bit farther, say I'm interested in, monitoring this model. And I, have sent some traffic a while ago. So let's go back to when I was sending traffic for this model. So on this page, this is the performance tab. Up here at the top, we have something called decisions. And this is really more like a business decision. So if there's some business specific question, a lot of our customers are interested in very particular answers. We allow you to track this over time. For this particular model, this decision, we're saying whether or not an individual is at high or low risk for churn. Below that, we are tracking accuracy. So, we can track accuracy, but we also have a variety of other metrics. So, we have true positive rates or recall, precision, the F1 score. Really, it can depend on what is best for your particular use case. And of course, for this, you would need the ground truth labels. And so here you can see for this model, the accuracy for quite some time was hovering around 0.8. And then we see this sort of sharp dip that happens. And it's dipping down to about 0.65. So, that's something that if this was my model and I was monitoring it, I would want to understand why there was this drop in performance. So we can dig into that further by heading over to the data drift tab. So what we're looking at here, the light blue line is our average prediction value over time, and the dark blue line is our prediction drift. Fiddler here is using the JS divergence to calculate drift. And so that's the dark blue line. And the first thing that I really want to show you is, for the performance, it really started to dip around April 11th. And you'll notice that we start to see that rise and drift for our prediction value around that same time. So we have this drift analytics down here. And if you select, say, what I consider to be the offending time bin, where the drift is the highest, my drift analytics below will update for that particular time bin. So again, we have all of our various features here. We have the individual feature drift for this time bin in this column. We have the feature impact over here. And then we have some metric that we call the prediction drift impact. And that is just very simply this feature drift times the feature impact. And it gives you this number. So the first thing that's jumping out at me is this feature number of products has this very high drift, much higher than any of the others. And we can see that it's contributing heavily, right, to our prediction drift impact. So not only, just to pause, not only can I see the, the prediction drift, but we allow you to monitor each individual feature's drift. So if you're curious at looking at some other value, you can see that, we can see that graphically as well. So going back to our prediction, and this is the probability that someone's going to churn. If I go, say, to an earlier time bin, number of products, again, feature drift is very, very low. And I can see after that, it's, almost an order of magnitude higher maybe. So definitely something I want to investigate further. We also allow users to track their data integrity issues. For this particular model, we have none that are registering, but we allow users to track things like missing value violations. So if you have null values that are coming in, we allow you to track, this again is for if your model is up in production and you're sending production traffic to us. So then you can check out type violations. So for example, if you're expecting for a particular feature it to be an integer and instead you're getting a categorical value or a string, we can let you know about that type violation. And then we also can allow you to see if there's a range violation. So the range we determine from your initial sort of training set, the range of values that you expect to see in your features. And if there's some very strange value coming through, we also will flag that for you. Similarly to the previous screen, if I click on a particular time and if there were data integrity violations here, this updates and can immediately let you know which feature is the one that is causing the problems. And additionally, we allow you to set alerts. So if I want to add an alert for this particular model, I can select alert type, and that can vary from your performance, your data drift, your data integrity, whatever you're interested in. I can choose the performance metric that I'm curious on tracking. I can select the bin size. I can either compare it to a previous window or a particular absolute value. So if I want to say, warn me if it's, less than a certain amount. And then we can either email you or have a pager duty set up. And actually very shortly, we're going to allow for Slack notifications as well. So going back to my particular case, right? So I had, that overview, right? We had this accuracy drop, then I see this data drift that's happening. And when I select on that time window, I'm seeing really it's coming from this singular feature number of products. So we can dive into that even further. So here we can look at the feature distribution, right? And so we're looking really, the blue is your production data and the orange is the training data. And you can see that there's already a discrepancy kind of between these two. We also allow for this average feature value over time, but because my time window is so small, that's not that helpful in this case, but it can be helpful in other cases. So I want to look into this further. So I'm going to click this, which is called Export to Analyze. It's taking me over to this Analyze tab here at the top. So we just shift from the monitor to the Analyze. And now we have, this is basically like a simple SQL query that we've set up. We allow you to sort of slice into your data and then explain what's happening. So, I can adjust this SQL query, say instead of looking at those two particular features, I want to look at all of my production data. So this is coming from my production data. And then, we've selected out that particular time range that where I saw that increase in drift. So I can run the query and then my production data here, is here. If I want to download that for any reason, you can easily download it and play with it in, say, your own Jupyter notebook. But additionally, here we have a lot of sort of the analytics powers sort of at your fingertips here. So we have feature correlation, we have feature distribution, we have feature impact, we have partial dependence plots, we have the slice evaluation, and then data set details, right? So if we start, say, at the slice evaluation, and this is really telling us, of our, any performance metrics that we have, and we can see them all easily here, the confusion matrix, a precision recall, sort of all right at your fingertips. So, for this particular instance, say I want to look at, what my feature impact is. So I want to maybe update the number of features a little bit. So the slice is the dark blue, and we can compare that to our data set here. So I always think that is a wonderful aspect of our product. And here we can see that number of products is actually contributing a lot more to our prediction. It has a larger feature impact than it did for our data set. Perhaps I want to look at my, feature correlation. So let's say I want to check out the geography versus number of products. And I can immediately see that the state of Hawaii here, it has this very anomalous behavior when compared to the other states. So seeing that, I want to dig into that even further. So I can, edit my SQL query to select just for the state of Hawaii. And let's see, what we maybe want to look at. So let's maybe go back to that slice evaluation that I had, right? So if now, now I'm just looking, I want to look just at my production data for the state of Hawaii. So I'm going to rerun this query up at the top. And immediately my accuracy, you can see, drops to 0.24. So now I want to see what is it for the rest of my states. So if I now edit that SQL query to say everything but the state of Hawaii, and actually my accuracy is almost 0.8, if you can see that there. So, really the model is only having problems in particular on the state of Hawaii and not actually on the rest of the states. So that can potentially be very useful depending on what my team decides. So, maybe we want to look at the feature distribution, say, of number of products. And so this is for all the other states but Hawaii. But now let's go back just to Hawaii. I can run that. And actually, that's the offending feature that's drifted. So pretty quickly, I've taken you through, we've been able to see that dip in accuracy and the drift that's happening. And we've really been able to sort of boil down using our Analyze tab, like where that problem is coming from, and see that it's not actually for our entire geographic region, it's just for one particular region. And something that would have taken me, I think, a lot longer to sort of sleuth out in my Jupyter notebook, Fiddler sort of allows you to do this like very quickly and easily. And again, if you set sort of an automatic alert, it can let you know sort of, while you're away, working on something else. And another thing, we allow you to sort of pin these charts. So I can pin this chart here to a team dashboard. And so this can be really a centralized place that you can see, that you can go back and share with the rest of your team. Sorry. So you can see here, you can share with the rest of your team. You can share the URL and people can examine what's happening with your model kind of in real time. So instead of passing, say, like a PDF or a CSV or something sort of in between your team, you really can sort of just have this centralized platform where you can examine together what's happening with your model. So, going back to this Analyze tab, like I said, I just want to make sure that we see, again, we have partial dependence plots, we have that feature distribution, correlation, and the slice evaluation. So it's a pretty powerful tool there. So, then now we have sort of this explain tab, right? So we can run this. This is, if you're more interested in kind of a deeper understanding of, what's happening inside of your model. So again, we can either look at the data set, your training data set, or we can look at your production data. So you can select the source file. Right now I have the training data sort of come in. You can add filters if you're, interested in diving into specific segments. So, say I want to look, at the feature geography and in particular for Hawaii, right? And so then I can rerun that, and that's from selecting from my training data just the state of Hawaii. If you want to drill down even further, depending on, your use case, for in particular, say banks often have to be able to give explanations to people why the model is making, individuals, why the model is making the prediction that it is. So, in this particular case, the probability of churn for this person, is a woman who's 37 years old, is quite high, is, almost 0.8. And so we do something called, I wonder why that's not coming up. We do a point explanation. So we do a point explanation, which really allows you to drill into an individual prediction. So, on this first page, this is something really that might be more interested to, say, business users who are a little less tech savvy. Sometimes you want to share information, and this could be very, apt for someone like maybe on the business analytics team who doesn't have as much experience with, model predictions. And so it's sort of just this high level here that you can share for kind of a non-technical user. And again, the prediction value is pretty high for this person. But then if we click over, say, we can do the feature attribution here, and this is maybe for, the more technical user. So we have our prediction, we have from this baseline. So there's always a baseline value here, and that's really, you can think of it as like the median value. So we're comparing to that. And so if you're looking, here we have our variety of features, and we allow you to sort of adjust these values and rerun them in order to see how the prediction would change. And so that's where our name comes from, is that it allows you to fiddle with these values. So this person has a fairly high predicted churn here. And so say I want to fiddle with the number of products, maybe go up to 3 products. We can now rerun this prediction with this edited value. And, her likelihood of churning has dropped, I would say, quite a bit, which makes sense, right? That makes intuitive sense. You can keep that compared to the initial feature vector that we had. So we can see our what our original prediction would have been and what it is now. And again, these are the, individual attributions for each feature that we can see here. It's sort of the tornado plot. So these are contributing negatively to this prediction. These blue ones are contributing positively. In this particular case, we're using like a fiddler version of Shapley values. We also have some other algorithms like integrated gradients, depending on what is most useful. And now we actually allow users to upload custom metrics. So we provide SHAP, Fiddler SHAP, and IG just sort of out of the box. But if you have a particular metric or explanation method that you are really interested in, either, monitoring or explaining, like, we can allow you to view those as well. So let's see, where else do I go? We also have sort of ice plots here, and you can fiddle with these values as well. So there's kind of a lot to dig into just on this individual point explanation. So let's see, the other thing that I want to show you all is that we also allow, so this is like IMDb movie reviews. So this is for, text inputs. So if we want to go to our explain tab on this, I can run this and you can see, this is like the sentiment value here. And if we do that, so again, we can see, global explanations. And for this particular case, you can see a word cloud of what are the, most positive, most negative words. But we also have this similar, global feature impact here. But going back, to this individual query, again, you can add filters depending on what you're interested in. But say I want to look at an individual point and do an explanation there. And so here we're using integrated gradients. Again, this is that sort of like business users view for the less technical users, but we can go to the feature attributions and sort of zoom in, and actually we allow you to edit this in particular. So you can take out a word. So blow up in this case is contributing very negatively to this score. So we can delete that word, rerun with edited values, and see if the sentiment analysis changes at all. So this is just to show you, and I think in this particular case, I did this earlier, I don't think it does. So I think that sentence is negative enough that even just taking one word out doesn't really change it, which is good. Yeah, so we have, text capabilities, for your NLP models. And then I also want to show you that we have now hybrid models. So this is something newer that we've developed. So this model in particular contains both tabular and text data. And we allow users to, explain and monitor this as well. So we're pretty proud of that, and that's pretty cool. So you can see I can do the individual explanation here. We're going to get the point overview. And so we're using, again, integrated gradients, but that it's deemed flex because we're using a combination of both tabular and text data. And here you can see, again, I can zoom into that text here, or I can fiddle around with, my tabular values and rerun. So, and finally, the last thing I'm going to show everyone is that we have this fairness capabilities as well. So now I'm jumping over to a project like it's a model census income. So this is from the US Census, and this is income data, okay? And so, this model is really, it's using a variety of demographic information here in order to predict whether an individual is making above or below $50,000. So, here we allow you to select, the big picture here is that we allow you to check your data set to see if it has any sort of bias or fairness issues, if your model has any bias or fairness issues, and then we provide some very commonly used bias metrics. So let's start, say with, we're interested in race, right? And we want to check for that. Now, of course, like AI ethical best practice is to never use a protected attribute, when you're creating your model and making predictions. So Fiddler allows you to upload, protected attributes as metadata, or you can use their proxies in order to check both your data set and your model for fairness. So let's go ahead and run this and see. So first thing we have down here for our data set fairness is a mutual information chart. So this is going to check, if there's a high degree of dependency across these features, right? And so, if you're getting a very high value for your protected attribute, then it's acting as a proxy for that protected attribute, and you may want to consider removing it from your training data. So in this case, it's looking good, and so that's great. We also allow you to check your label distribution across all your outcomes. This is another very important thing to check. You want to make sure that you have balanced label distributions for all of your protected groups. Otherwise, you may be making some missteps. And so if we head over to model fairness, so we can look at model outcomes here, right? And so we can look at this grouped view or stacked. And really, the thing that might jump out is that, we're getting a much higher positive outcomes for the white population. Now, in this particular case, we're just looking at census income, right? So this isn't necessarily a problem, but you can imagine, depending on your use case, if you have one demographic that is getting a lot higher positive outcomes than your other demographics, that's something that you would want to then look into. And so a sort of continuation of that is we have this model performance in a variety of metrics that you can look through. So we have true positive rate, true negative rate, false omission, false discovery, false negative, and false positive rate. And really the key here is you want these to be as equal as possible across your groups. And so this can be another way that you can check to make sure that your model is performing fairly across all demographics. And then finally, here we have some very commonly used bias metrics. So we have disparate impact and equal opportunity and demographic parity and group benefit. In particular, we published a paper, I guess earlier this winter, time is flying, using an intersectional lens. It's wonderful to look at, one dimension on your protected attributes to check for bias, but a lot of recent studies have shown, including with Timnit, Gabru and Buluimi, that if you actually look in two dimensions, so say we look at both sex and race, often bias can be obscured. So we allow users to really look at multiple protected attributes at one time. You can rerun the values for both race and sex at the same time to make sure that you're not being unfair in one dimension. So if we come back, for example, to our model outcomes, we see, that white males are having a lot higher positive outcomes than the other groups. And again, for the model census income, this is sort of just a reflection of the reality of our country, and not something that you would have to adjust. But again, you can imagine, depending on your use case, if you have an outcome like that, it would be something that you would want to look into. And so, going back to these metrics here, so we have this min-max ratio, which allows you, really what it's doing is it's taking the subgroup that has the worst score. It's a pretty simple ratio, the subgroup that has the worst score versus the subgroup that has the best score. And so it can kind of tell you in a glance. So really you want this number to be closest to 1. And that means that you're, doing a pretty good job on fairness. And the farther away it is from 1, the worse you're doing. So that number can kind of tell you in an instant, in terms of these metrics, how you're doing. And so that's all we have for our demo today. Maybe I'll stop for questions. And I know we actually have a lot of time. So Henry and Magda and I talked about maybe doing a repeat depending on if people can make it later. So with that, I will pause and see if there are any questions.
I actually have one from the Q&A. Can you see the tab?
Yeah, what is the difference between decision and accuracy? Is that the question?
No, on the Q&A.
Someone asked,
Yep.
Is it the model performing fairly or the data set has an issue?
Yeah, so again, this allows you, I think, a window into both. So we can see here, this is really, I don't know if that question is particularly asking with this outcome, so I don't know, I guess, can the people speak on this? No? Or is it just through text?
If they would like to come on to this platform, they can. I think you can ask to share your video and audio, and I can pull them up.
It's okay. I mean, if they just want to chat more, that's fine. But this is just to say, it's hard to triage it. I think, we allow a window into both, right? So we allow you to check your data set for some very common, issues. And then the model fairness, we say model fairness, and you're right, that could be stemming from something that's happening within your data. And again, this can just empower the user to sort of like take it into their own hands and say, hey, there's a problem here. Let's try and figure out what's going on, what's wrong. So it may be something about the way your model is working. It may also be something with your data set.
Another one.
Yeah,
go ahead, Mary.
Someone asked, do you store all the model prediction in the platform or just a sample?
It is a sample. It is a sample, and I actually, my knowledge might just end there. And so if you want additional knowledge on how that sampling is done, you can email us and we can get back to you.
But we do run it on-prem.
Yes.
Yeah, just to reiterate, we run either on-premise or in the cloud, whatever cloud vendor you might be using, either Azure, GCP, AWS, or it can be in your own private VPC. I'm going to ask someone to clarify this question. Where do you store it? What are you referring to?
Are they talking about the production data?
Yeah, I just asked if they can clarify on that one.
Does this person mean the production traffic?
So the question was, where do you store it? In the database or in a bucket as a CSV? Yes, and They're asking about the prediction.
Okay, we are speaking to our engineers right now to find out the correct answer for that.
Yeah.
But just, and Mary, you can correct me on this one, but think of Fiddler as like something that's running in parallel or as a sidecar. So all the decisions that are being made are passing by, like the decision will come to you, but then it's also going in parallel with Fiddler as well.
That's right.
So the decision is not reaching Fiddler and then to you, if that makes sense.
Can move to other questions. So if you had modifiable SQL queries for dataset slices, do you have means to restrict the queries available there by arbitrary rules, as in a case where the user of this tool doesn't have access rights?
Yeah, actually, so that is something that I believe we are working on. So one, I would say that we don't necessarily have that in particular for the SQL query, but we are working on abilities, for some people just to be viewers of the data and other people, to have write, like read and write access. What is the other thing I wanted to say about that? Oh, two is, of course, we really do care about, like protected data, right? So we have a lot of clients where, the data is sensitive, it's, so we have ways to sort of help and facilitate with that as well.
Someone else asked the question, is the machine learning model your starting point for further analysis, since the initial architecture showed Fiddler coming as a layer on top of clients' models? Yes. So we're not really a modeling platform, so we're not really building those models for you.
Yeah.
But what we are doing is we're providing a platform so that you can monitor that model that you built, or you can explain that model or check if that model is making like a fair decision.
Yeah. Yeah. So we don't help with, model building or hyperparameter tuning or any of that kind of stuff. Yeah.
So going back to the previous question about where do we store model predictions, we do store them in a DB. Same with the on-prem case as well. Okay, and then there's a new question. So when you monitor the prediction, do you log the value for each feature pre-processing or post-processing?
So when we monitor the prediction, we have, so I'm not quite sure what you mean by pre-processing. I don't know if you want to, I see. Like, are you saying, and let me assume this is what you mean. So it would be, if you're meaning when you're developing your model and you have some, pre-processing steps and then you make your prediction, we're looking at it at the post-processing step. So all of the pre-processing would happen before that. We then ingest the prediction after that point and then make the comparisons. And if you were asking something else, you can clarify.
So someone asked, do you charge per model, per prediction, per user, per CPU?
Yeah. So go ahead.
So I was going to say, in terms of pricing, we're not really per user. So you can have as many users as you want in the platform, but the charge is going to be dependent on whether you're just looking for monitoring or if you're looking for explainability. That will change, but it will be per like server if you're on-prem. And we're also going to charge on, wow, I forgot what I was going to say. It's also based on like how many decisions you're sending or how many decisions are made by the model. But obviously the pricing is going to be varying on like really in each specific use case. Two more questions. Okay. So I'll read the question for everyone. It says, if your model is untrained on unfair data, then what is the prediction? What if the prediction is faithfully going to do to reflect that? So what is the purpose of posterior analysis?
Yeah, so I think that's a great question. I think, generally checking for model bias and fairness is complicated. And so this really gives you sort of a first stab at the window. And of course, like if your data is already unfair, one, we allow for data set checks, right? So you can look again at the mutual information chart and see if anything's acting as a proxy, and hopefully that'll start to give you a window. I think also our label distribution, right? But so in that case, your model prediction is just going to reflect that, and you're right. And I think these can really just give you windows then to sort of arm the user to go back and do more due diligence and see. But I would just say, sometimes the model itself can be biased or have biases built into it. So even if your data is a pretty good data set, the way that a user is building a model can also be unfair. So we provide checks on both of those places.
So someone asked, how do you measure a server? So we measure, so it says T2 to XL or the equivalent of that. That's a little bit past my technical debt, so.
Yeah, same. Don't know the answer.
Someone asked, you mentioned having your own version of SHAP. How is it different from open source SHAP?
Yeah, so we actually put out a paper on our version of SHAP, and it really has to do with how we decide to use your sort of background or your baseline. So every time you're using SHAP, right, it's like a permutation. So you're sort of removing a feature, rerunning the model, and seeing then how much that feature was contributing, but you need a baseline value. And so we actually use like a sort of a distribution of baselines. This then allows us to have an error bar. So I almost should go back and show, but basically if we look at regular SHAP, there's no error bar, and this allows us to give an error bar on those attribution values. But we have a paper that we published on this that's available and online.
And also feel free to connect with us on LinkedIn as well. Yeah. If you have like further questions, we can help answer. So I'm not sure if I pronounced his or her name right. Latit asked, in essence, are you conducting policy prescriptions? Correct.
You mean in terms, I think this is that same person that was asking about fairness, and we are not. So again, fairness and bias is very specific to the use case, right? So it's really going to depend on what is fair in one model. Anyway, it really just depends on your use case. And so we are not giving, policy prescriptions. That really is going to be dependent on the user and their use case. And so we are just trying to empower the user to be able to get insights into what is happening with their data set and their model by arming them with these metrics easily in one place. But then it's up to the user to really understand their use case, because we can't know. Right now I'm seeing the other one. We can't know what's best practices for you. Oh, I don't think I mentioned median. If I did, that was an error.
So the next question is, so I heard about Lime. Can you explain when to use SHAP and when to use Lime?
Oh, yeah. So we don't provide Lime explanations. And I think, we prefer, I think, SHAP, but, Lime is also great. They're both sort of, permutation-based explanations. So they can be very similar. And just in the case of Fiddler, we have SHAP and then our particular version of SHAP. I don't think I can tell you when it's better to use one or the other, but they're similar explanation methods.
So I think someone asked.
Yeah, thanks. Also, Latit, hi.
Yeah.
Yeah.
So someone
I
asked,
wish that I could see your faces. So we don't really have time series capabilities at this moment. Someone's asking, can you explain time series
but
forecast?
it's in our product roadmap, and it's something that we're working on.
Thanks, Magda. And Lated, I hope I'm pronouncing your name right. You're the only non-anonymous person that's chatting with us. So if I'm pronouncing your name wrong, I'm very sorry. So we also, so for the point explanations, we also use,
Lalit.
Lalit, sorry. So Lalit, hi. Apologies for getting your name wrong, like multiple times. Yeah, so for local explanations, we use both SHAP, we use Fiddler SHAP, and we use IG, and the user can, if your model is differentiable, and the user can select. So when I was doing those, zoom in on the individual point, that still was using SHAP. Yeah, I believe we do. Do you guys know? Do we integrate with Prometheus?
I think we do. Yeah.
Yeah.
Lalit.
We currently do not support unsupervised learning, but that's something that is in our product roadmap.
Yeah.
For others, the question was, what about unlabeled data or unsupervised learning?
Yeah, and so like exactly what Magda just said. So in our roadmap for unsupervised learning, but then for unlabeled data, you can still sort of track your prediction drift. And so that can still be a great indication over time. So you won't get your accuracy metrics, but you can still track prediction drift. And that can still be helpful while you're monitoring.
So someone asked, so to get model performance, how does the user label production data? Do they get an alert? Sorry, the questions keep moving down.
Yeah.
Do they get an alert that is data that is ready for labeling?
So that would be, on the user side, right? So assuming, you would know better than we would know when your labeled data is available. Ready for labeling, again, that would depend on, you and your use case and what works best. I think we could work with you if there's a particular time, so again, we're not really involved in that process. And I think that's really up to the user.
Do you handle correlated features for SHAP?
Do we handle do we handle correlated features for SHAP? So no, I don't believe that we really help with that. I mean, going back to our fairness, we have that mutual information chart that can sort of let you know if you have something like that happen. We also have, in our analytics, the feature correlation. So if you have something like that's happening, we have other ways for you to look into it. Otherwise, our SHAP algorithm will just, run. And Lali, you don't have to stop. Yeah, that's a great question. So Lali just asked why JS divergence. Excellent question. And actually, we want to expand our monitoring metrics. So that's just one place that we started. But we are planning, again, in our roadmap, the data science team is looking into other drift metrics. And so we're going to expand. So yeah, it's kind of just where we started. And we plan to go with, more metrics to, again, arm the users. So. Ooh, no, I don't believe we have any special support for unbalanced data. Not at this time.
I think we have about 15 more minutes. So we got some time for some questions.
Yeah. How do we compare drift with categorical features? Yeah, I feel like I'm not actually, I believe we do use the same metric, and I think it's just with them, the feature distribution, but I feel like perhaps I'm not armed to answer that question properly. So maybe I'll. Don't know. Sorry, Lali, will you explain yourself more? Yeah, and anonymous, I don't know. So I think that might just be the limit of my, yeah.
2 questions are combined.
I don't know.
Yeah, Lalit, I think we're gonna need you to explain a little more on what you mean.
Are encoded first. High cardinality features are encoded first. Oh, I see. Explaining them seems problematic. Yeah, well, so we want to do a little, we feel like our explanations are pretty faithful. Yeah. And then the other person is asking about PCA or TISNI. So again, we don't, okay, yeah, we don't help users with, sort of dimensionality reduction or anything like that.
Hey, Lalit, if we're more than happy to arrange a quick 10-minute call if you like. You can connect us on LinkedIn, or I don't know if we can type our emails here. Here. I just posted my email on the chat. So if you have further questions, feel free to send it to us. Perfect. Yeah, he will connect with Mary.
Great. Yeah, wonderful.
So do you generate alerts in real time, or does the feature drift check-in done every day?
Oh, go ahead.
So you can create alerts in real time, and it really depends on what your so for example, some teams want to monitor on a weekly basis, or some want to monitor on an hourly basis, but those alerts happen in real time. So if there's any type of drift, you will get alerted either through PagerDuty, email, and we also have a Slack integration coming up. Mary, did I explain that?
Okay. Oh, yeah.
Those questions. Oh, here we go.
Can you hear me?
Yeah, hi.
Hi, Mary. Thank you very much for indulging me all this along.
Oh, yeah.
One of the questions I had was basically based out of my own experience. So when you have high cardinality and when you have categorical features, so most of the models, most of the demos generally refer to numeric values, right? Which is what the machine learning algorithms expect. Now, the problem arises when you have high cardinality and high categorical features, right? So you have to encode them, and, suppose there are hundreds of, values, unique values in a feature. So when you do the sharp values, the summary plot, it still plots at the global level, individual.
Oh,
So like when you're trying to explain, you're trying to explain
I
the
see.
feature, right?
I see.
But when you start
Where
doing the
your question
encoding,
is.
it goes to the individual values within that features. And that
I see.
seems meaningless, right? So how do you handle it?
I see. Yeah. So one, and again, this is pretty similar, I think, to like we. So I almost want to. Can you mute again? And is it pronounced Lalit? Yeah.
Lalit.
Yeah, Lalit. So if there is a high cardinality, you're right. We end up showing the individual attribution for each one. And so that I think can become difficult for users to sort of understand. We're sort of working on a process of grouping them. So then you can sort of see it as a total. We don't have that quite yet. But now I'm really understanding what your question is. And that question makes a lot of sense to me. But we're looking into a way to sort of group them. So then you can sort of get like a summary value of that chunk. And you're right that if there's a 10 and we similar issue then say you have 200 features, do you know what I mean? And a lot of them have a lot of small individual values. So again, each use case is going to be slightly different. And we're working on ways of really allowing, insights to be more specific. So you don't get lost kind of in the muddle of a high cardinality, categorical feature there.
At the local level, if you're trying to explain at the local levels, so right, you're doing explainability, and the example you did was random forest, which is what essentially Sharp was initially built for, tree-based thing. But when you start getting into anything else, so there are kernel explainer and all those kind of things, but I've tried them and they have been problematic. It's not been really successful.
Yeah. So we also have, again, integrated gradients. So really depending on your use case. And then the other thing that we allow people to do is if you have like a custom explanation method that you're interested, in that say you don't want to use Shop and you want to use something else and you feel like that fits your use case better, we allow the user to use those instead. So, I didn't have any of that plotted up there, but like if there is something in particular, you're like, this isn't going to work for me, this other explanation is going to work better, we can really work with the user there.
But the user wouldn't know, right? I'm technical, so I know this. You are technical, you know this, but the user wouldn't know. So like I have about 40, 50 features and 39 of them are basically categorical. So I'm encoding each one of them. So that kind of expands the dimension to 500, 300, what have you.
So again, our product is built for, people who have experience with, machine learning, so it isn't a business user, right? Like our product really is geared towards the MLOps and the data science community with people who should have some understanding. We also can arm people, if something is going awry, we're happy to sort of chat and triage and figure out what would be best for people's use cases. But, this really isn't intended for someone who's going to have no idea about, machine learning models or any of these things, so.
Okay. All right. Thank you.
Yep.
Thank you.
And it's also nice to see your face after chatting with you and
yeah, I kind of figured I owed it to everybody because I've been hogging the limelight and unnecessarily because my questions were very specific, right?
I loved your questions. They were great.
All right.
Yeah. Thank you.
Thanks.
Bye.
Yeah.
I think that's it. I don't see any new questions.
Yeah. Yeah. I don't know if we do have like 25 more minutes. I don't know if any new people have joined who didn't get to see the demo. If that's true, we can go back through the demo and you can just drop that sort of in the chat. Thank you, Tina. Yeah.
Great.
Or we can give people some time back for, grabbing coffee before the next session.
Yeah, I think if there's no more questions, then we can probably end it here.
Okay, excellent.
All right, thanks everyone.
Yeah, thank you. And again, we mentioned before, we have, we're on LinkedIn, I'm Mary Reagan, you can find us there. If you have further questions or if anything was unclear, we're also happy to send people, some of our academic papers that we've published, including our version of Fiddler Shop. So please reach out to us.